Hello again, everybody. This is Lorenzo Perella with Clark Wellman's 116 physics class, coming at you with lab number 4, pendulum period and frequency. For this one, we'll be discussing the movement of a pendulum and finding its various components from the period, frequency, as well as determining the error percentages and other references. The end result goes back to this graph, table. It is a table in the first column where we have an amplitude of 20 degrees and one length of a meter. Showing in this, here is the pendulum and this is the length of the string. It will be brought out to a theta that is 20 degrees. And from there, we measure how long it takes for it to complete 10 back and forth movements. We take that time interval and divide by 10 to get the measured period. The reciprocal of that would be the hertz. Then we do the same thing again for the frequency. And then we figure out the period and frequency based off the theory. And that theory relates to the equation here, which states that the period is equal to 2 pi times the square root of the length divided by g. And then the frequency is the reciprocal of that. So from our results, found that in the first one, when it was 1 meter, the measured period for 10 periods was 2.045 seconds, and that the frequency was 0.488 hertz. And then when we changed that to 20, it was 0.4905 hertz. And then when we do the equation of 2 pi divided by my bad. 2 pi times the square root of the length of the pendulum divided by the gravitational constant, which on Earth is 9.8 meters per second squared. We find that the period there would be 2 pi times 1 meter divided by 9.8 meters per second squared, and we get 2.007 seconds. We find the inverse of that to be 0.4982 hertz. Now, in order to calculate the percent error, we take the true value minus the theory value, and the absolute value of the difference divided by the theory times 100 will give us the answer. In this case, we take 2.045, which is what we measured, and then we take the theory value, divide by that theory value of 2.007, and we find that the error was 0.189%. And this is good within acceptable margins. For in order for something to have an acceptable percentage of error, it has to be between 0 and 5%. And this falls well within those margins. And this can be done with every other length. And there's a trend in that when the length becomes smaller, the period becomes smaller, which then creates a higher frequency. And we can also see that there was a smaller degree of percentage error. We made sure we got each one down. And then later we did the same thing with the gravities of the moon and Jupiter to find the g constant. Though in accordance with our directions, all I really need is to go over the first part. So as that, we've covered all the bases. Thank you. This has been Lorenzo Perella for Physics 116 with Clark Wellman. Have a good day.